Hi everyone, how are you? All are fine? Okay, this is a third lecture of biomolecules. What I completed till now, we just started the biomolecule chapter. What is carbohydrate? Okay, carbohydrate compound. What is the modified definitions of carbohydrate compound? That stuff completed. After that, we'll go for the classifications of carbohydrate. Now, after classification of carbohydrate, we are going to the simplest form of carbohydrate, which is simplest form of monosaccharide, which is glucose and fructose. Now, reactions of glucose. What is the IUPAC? How can you write down the name of this one? Okay, what is the structure of glucose, ring structure of glucose, what is anomeric carbon? After that, mutar rotation stuff I already discussed. After mutar rotation, we can say fructose. Now fructose, the structure of fructose, this stuff already discussed. Okay, okay, is it clear? Now today we will start from reaction with HI. How the reactions with HiO4, sorry, reactions with HiO4. So write down the chapter name, biomolecules. Now, biomolecules, today we are starting with reactions with HiO4. Reactions with HiO4. Now, for reactions with HiO4, if you write down how the reactions takes place, this reactions is important, and after that, we will give you some shortcut. CH, CHOH. Okay, this is vicinal diol. Okay, this is one of the important. This is a vicinal diol, one of the important reactions. Okay, remember vicinal diol. When it react with HiO4, it form 2 moles of acetaldehyde. Now tell me what is the role of HiO4? What will be the oxidation state? If you write down the oxidation state of iodine, which is 7. Now, what is the most highest oxidation state of iodine? That is plus 7. So in this case, iodine actually appears with its highest oxidation state. So from here we can say this is per iodic acid. For per iodic acid, iodine is present with its highest oxidation state. That's why this per iodic acid HiO4 act as a strong oxidizing agent. Okay, this one acts as a strong oxidizing agent. Now, how the reaction takes place? If you write down the mechanism, if you write down the mechanism is looks like this way. CH3. Now, what is the structure of periodic acid? Okay. Now, in this case, lone pair is present over here. This lone pair attacked at this position. This bond becomes negative charge. After that, another lone pair is present over here. This can attack at this position. This bond comes negative charge. Okay. Now, when this one forms negative charge, and this hydrogen, and remember one thing, after removal of negative charge, it will accept H plus ion from this stuff. Okay, okay, here the OH plus is present, this O minus can accept this one. So what will be the structure? If you write down the structure is looks like this way. Okay, so it looks like this way. Now, I already told you geminal diol is highly unstable. Geminal diol is highly unstable. That's why one water molecule removal takes place. Now, after removal of water molecule, what you get? You get CH3, which is attached with oxygen, double bonded O, double bonded O. Now, in the next step, if you write down the next step is like what? This bond comes here, this bond comes here, this bond comes here. So what you get if you write down this one actually contains double bonded O. This one is also like double bonded O, and this stuff which is becomes HiO3. Okay, this stuff which becomes HiO3. Is it clear? Any doubt regarding this stuff? Okay, is it clear? Okay, another OH is present, I think. Just a minute. Sorry, here another OH group is present. I forgot to write this one. Okay, so what you get after taking this reaction, we get CH3 CHO plus HiO3. Okay, and this HiO3 where iodine which exists as a +5 oxidation state, this is called as a iodic acid. So basically, if you write in the previous reactions, if you write down these reactions HiO3, this +7 converted to +5. That means in this particular case, itself reduction takes place. Reduction takes place. RED represent reduction takes place. Okay, so due to reduction, that means itself reduce. That's why HiO4 acts as a strong oxidizing agent. Okay, is it clear? Any doubt regarding this part? Now, what is the shortcut? If you write down all the reaction, it will take time. So that's why always go for the shortcut method. Shortcut method is very, very interesting. Don't go for the logic for shortcut. Just remember as a shortcut. Look, CH3, CHOH, again CHOH. Now, whatever vicinal diol system is present, you have to break this one and add OH from here, Okay, that means both side you have to add one OH group. So what you get? You get 2 mole of OH, and in the next step, water removal takes place. After removal of water, it forms acetaldehyde. Okay, it forms acetaldehyde. Okay, now why this reaction takes place? In this case, if you check the previous case, how many total? 1 2 molecule. Here total number of molecule is a 3. So that's why we can say this reaction is a entropy favorable process. So we can write this reaction will be the entropy favorable process. Entropy favorable process. And due to entropy favorable process, we can say del S value is positive. That's why this reaction takes place. Is it clear? Any doubt regarding this stuff? Do you have any doubt? This stuff is clear. And remember here also water we get also 1 mole of water. Now I am giving you some questions regarding this HiO4 which is related to biomolecules. Try to solve it. Okay. 4 questions I am trying to giving you quickly. In this case, X mole, X HiO4. What will be the final product that you have to write? And what will be the value of X that you have to told? Okay. Second question. Again, similar way. X mole of HiO4. What will be the final product that will you have to tell? What will be the value of X? Okay. Now question number 3. Okay. Now XHiO4. What will be the value of X that you have to tell? What will be the final product also you have to tell? Okay. Now the last, what is this one? This one is basically glucose, D-glucose. Okay. And the last question giving you, try to solve it. Again, XHiO4. What will be the value of X that you have to told? What will be the final product that you have to told? Just giving you only 2 minute time. Try to solve it. Quickly try to solve it. Done this one. How can you solve? Going to the first question, go for the vicinal diol system. How many vicinal diol system are there? 1, 2. Okay, 2 vicinal diol means 2 mole HiO4. So X value is 2. Now what will be the final product? Now you have to add OH over here. You have to add 1 OH over here. Again, when you break this one, OH addition takes place. So what you get? 2 mole of CH3 CH OH. Now after removal of water takes place, after removal of 2 mole of water, we get 2 mole acetaldehyde. That should be the one product. And another product, if you write down this one, CH, which is connected with OH, again 1 mole of water removal takes place. Just a minute. Again 1 mole of water removal takes place. So after removal of 1 mole of water, we get OH. So basically this one is a formic acid. Okay. Now if you write down here 1, 2. So what will be the X value? X value is 2. What will be the final product? If you write down the final product is CH2OH connected with OH. Okay. So in this case, 1 OH you have to add, another OH you have to add, another OH you have to add, in this case another OH. So from here you get what you get? You get formaldehyde is CHO. Okay, CH2O. If you write down second one, CHOH. Now again 1 mole of water removal takes place. After removal of 1 mole of water, you get HC double bonded OOH, formic acid. Okay, and third product, if you write down CH3 CHOH, removal of 1 mole of water, you get both cases water removal takes place. Actually you get CH3CHO. Okay, now also remember HiO4 can react with, it can react with vicinal diol system as well as it can react with alpha hydroxy carbonyl compound. Alpha hydroxy carbonyl compound. Now this one is the carbonyl compound. This position will be the alpha position. Now how can you break? Break here, vicinal diol. So what will be the number of arrow? The number of arrow is 5. So X value is 5. So basically 5 mole of HiO4 required. Now what will be the final product? If you write down the final product, OH addition takes place here. One OH addition from here, another OH from breaking this one. Again OH, OH, again OH, OH. In this case, again you are adding OH, another OH. So if you write down this one, okay, another OH you have to add here. If you write down up to that part, look, C double bonded O H present, OH is addition takes place when you break the first bond. In this case, 1, 2, 3, 4, 4 cases, you write down like this way. OH is present, OH is present, another mole of OH is present. Now just removal of water. So what you get? You get 4 mole of HCOOH. Now when you add these two, we get 5 mole of formic acid and 1 mole of, from here, CH2 OH, OH. From here you get 1 mole of formaldehyde. From here you get 1 mole of formaldehyde. Is it clear? So D-glucose when react with HiO4, it gives 5 mole of acetic acid and 1 mole of formaldehyde, and the reaction is very, very important. Is it clear? Any doubt? Do you have any doubt? Now again in this case, this one is the alpha. So this bond will break 3, 4, 5. 5 arrow means X value is 5. Okay. 5 arrow represent X value is 5. Very good. Now what will be the product? Add OH over here. Okay. One OH over here, another OH over here. In this case, OH, OH, again OH, OH, again OH, OH, again OH. Now if you write down the upper stuff, what you can write? CH2OH, CH2OH, which is directly equivalent to the lower one. So can I write 2 mole? So after removal of water, we get 2 mole of formaldehyde. That is one product. Now when this bond breaks, that means the middle one, this particular stuff, what you get? C double bonded O with OH, OH. Water removal takes place. So after removal of water, you get carbon dioxide. Okay, so 1 mole of carbon dioxide removal takes place. Now, if you write 1, 2, in these 3 cases, 1 cases, 2 cases, and third one. So in these 3 cases, you can write CH, which is connected with OH, OH, as well as OH. Now water removal again takes place. Now after removal of water, you get 3 mole of formic acid. So when D-fructose, this one is what? D-fructose. Now after D-fructose, when react with HiO4, it gives formaldehyde, carbon dioxide gas, as well as 3 mole of formic acid. Any doubt regarding this part? Do you have any doubt? Do you have any doubt? This stuff is clear. Then we are moving to the glycosidic bond. What is glycosidic bond? Okay, write it down. Take a note. Note is very, very important. Take a note quickly. Moving to the glycosidic bond. Done. This stuff completed. Next, write it down. The glycosidic bond. What do you mean by glycosidic bond? Glycosidic bond. What is glycosidic bond? AOH present, BOH present. Glycosidic bond. Remember one thing, A is one monosaccharide. B is another monosaccharide. Glycosidic bond means removal of water takes place. Now, after removal of water, what you get? OH and H elimination takes place. Now, what you get after taking this one? A, O, B. This is present. Okay. This is called glycosidic linkage. Glycosidic linkage. Okay. Now for glycosidic linkage, what is glycosidic linkage? We can say it is basically oxide linkage, as well as if you write down this one is also ethyl linkage. So just write down what is glycosidic linkage. Basically a oxide linkage. Basically a oxide linkage which connects to monosaccharide. Connects to monosaccharide unit together. Monosaccharide unit together. Okay. Is it clear? Any doubt regarding this part? Do you have any doubt? Any doubt? And remember, this is the first point. Second point, this is also an ethyl linkage. Ethyl linkage. Okay. Now, glycosidic linkage can be classified into two parts. Glycosidic linkage. It can be classified into two parts. One is the alpha glycosidic linkage. Another is a beta glycosidic linkage. Now, alpha glycosidic linkages looks like this way. Basically, oxygen, in this case, linear connection takes place. Here, linear connection. Here, the linear connection takes place. And beta glycosidic linkage case, the angular connection takes place. Angular connection means looks like this way. Okay. So, in this case, angular connection takes place. Okay. Now, we are moving to the disaccharide. Today we will discuss only one disaccharide unit, that is the sucrose structure. After sucrose structure, another two are there. Then we'll go for the polysaccharide. Okay, so just write down. So monosaccharide stuff completed. Next we are dealing with disaccharide. For disaccharides unit, remember for disaccharides case, first is sucrose. Okay. Now, what is the formula for sucrose? Sucrose formula is C12H22O11. Okay, sucrose. Now, sucrose is known as a table sugar. Next, C12H22O11. When it hydrolyzed, it forms C6H12O6 as well as C6H12O6. So we get alpha glucose and beta fructose also. Okay, and in this case, this movement is dextrorotatory. So what is present? Alpha glucose and beta fructose, and rotation is third point. Rotation is dextrorotatory. Okay, dextrorotatory means positive rotation takes place. Now, if you draw the alpha glucose structure and beta fructose structure, how can you write? Just a minute. Okay. In this case, just write down first alpha glucose. Now, alpha glucose case OH, H, again OH, H, you all know that. OH, H, OH, H, CH2OH with H. This is the alpha glucose. Now we are trying to draw beta fructose. Now, before drawing beta fructose, I am rotating this beta fructose by 180 degrees. Okay. Now, after rotation takes place, what you get? You get this type of structure. Basically, anomeric carbon comes here. So we can write CH2OH takes place here. This one is the OH, OHH, OHH, in this case, HCH2OH. Okay, this one about beta fructose. Now, after that, what is happening? Water elimination takes place. Now, after elimination of 1 mole of water, we get sucrose. Now, what is the structure of sucrose? If you draw the structure, it looks like this way. CH2OH, H, OH, H, OH, H, H, OH, okay. This one comes like this way. Okay, this is about fructose. This is about sucrose. Now tell me, in this case, at which position? Which position? For this particular carbon, this one, and this particular carbon, this one. Now this one is basically, this one is a second carbon. If you write down for glucose case, this one is the first carbon, C1. If you draw the anomer, if you check the anomer, and this anomer is basically for fructose, this one is a C2. So that's why it's basically 1-2 linkage, and linear movement, linear direction takes place. So from here we can say this is a alpha. So what is the name of this particular linkage? Remember, this stuff is not a carbon. This one represent a linkage, This one represent a linkage. This is not a carbon. Now, what is the name of this particular linkage? This linkage is basically, we can write, this one is the alpha 1,2 glycosidic linkage. Okay, alpha 1,2 glycosidic linkage. Any doubt regarding this part? Do you have any doubt? Okay, now suppose you all know this important reactions. If you go through your aldehyde ketone chapter, this reaction is present. RC double bonded OCl. What will be the reagent? What will be the final product? This bond comes here. Here negative charge, again negative charge comes to double bond. This one takes place, and the mechanism, which is SNAE mechanism, what you get R O C double bonded OR. If this one is the R prime, I am taking this one. Is it clear? Any doubt? So basically COCl, this type, this one react with where free OH is present, where free OH group present. Now in your question paper, question can appear like this way. Suppose sucrose, when react with HiO4, X mole required. When it is react with CH3COCl. Y mole required. Now, what will be the product that is not given? What will be the value of X plus Y? Solve it quickly. Quickly try to solve it. Done this one. Now, how can you solve? CH3COCl react with free OH. Now, how many free OH present? 1, 2, 3, 4. Just mark all the free OH. 5, 6, 3, 4, 5, 6, 7. So, how many free OH present? Just mark this one. Okay, that is the main funda. First, you have to mark how many free OH group present. Is it clear? Okay. Any doubt? Do you have any doubt? This stuff is clear. Okay. Okay. Also another thing. There is a mistake. What is the mistake? You have to check. Na? This group is CH2OH. Okay. And this OH is also free OH. So total number of free OH is 8. That's why Y group is 8. Now, what will be the HiO4? HiO4 can react with only vicinal system. Now, find out the vicinal system. This one is a vicinal system. One. This one is a vicinal system. This one is a vicinal system. So that's why X value is 3. So what will be the X plus Y value? 3 plus 8. The value is 11. Is it clear? Any doubt? Any doubt regarding this part? Now we are moving to the invert sugar. What do you mean by invert sugar? Now, invert sugar is basically sucrose system. Okay. Now, sucrose system where alpha sucrose we are taking positive dextrorotatory movement. Dextro system, when it react with H3O plus, that means hydrolysis, we get fructose and glucose. Now, when you pass plain polarized light over here, when you pass plain polarized light over here, you get levorotatory movement anti-clockwise. Anti-clockwise. That means levorotatory. When you passed, we guess in this case clockwise. Clockwise. Now, clockwise movement means this one is a dextrorotatory. Dextrorotatory, which is positive movement. Levorotatory, which is negative movement. Okay. Is it clear? Now, if you put this sucrose solution, over here, glucose plus fructose takes place. Now, for sucrose is a dextrorotatory, you are using dextrorotatory system. Now, this one becomes dextro, this one becomes levo. But remember the theta value for fructose, which is very, very greater than theta value of glucose. That's why levorotatory movement gets dominate. So, which one is a more dominating factor? This one becomes more dominating factor. Dominating factor. Now, why sucrose called as a invert sugar? You are putting plus in this particular solution, you are getting negatives. That means you are putting dextro, you get levo. That's why these are called as invert sugar. Why we get levo? Because theta value for fructose will be very, very high as compared to theta of glucose. That's why theta of fructose will be the dominating factor. So just write down invert sugar. What is invert sugar? Invert sugar is basically change in optical rotation of a molecule in general. We are using sugar from dextro to levo and vice versa. Okay, dextro to levo. So if you put positive direction, you will get negative. If you put negative, you will get positive. That is about inverse loop. Okay, so that is the end for today. What I discussed today, we just discussed today what is the reactions of HiO4 disaccharide. In disaccharide, I just completed the sucrose stuff. So next class we will start with lactose and maltose. Okay, then we will go for the polysaccharide and epimers. What is epimers that I have to discuss? Then we will go for the polysaccharide. Is it clear? Any doubt? Okay, that's the end for today. Bye bye. Take care till then. Bye bye.